Hello, math friends. Welcome to A Squared Math and Stuff. In today's lesson, we are looking at the introduction to limits using direct substitution. And that's exactly what we do. We look at what x value we are approaching. We're going to actually substitute in that x value into our equation that we have. So let's go ahead and do this. This is the same type of thinking as back in algebra when we had f of 4. And then we were looking to substitute it into the equation x minus 1 over x squared plus 2x plus 3. That's essentially what we're looking at right now. And we are going to directly substitute into the equation just like we did way back in algebra. So let's go ahead and do that. Let's plug that 4. I got the 4 from our c value. Let's plug that in. Our numerator, we will have 4 minus 1 divided by 4 squared plus 2 times 4 plus 3. Work that out. 4 minus 1 is 3. We end up with 16 plus 8. 16 plus 8 is 24, plus 3 is 27. Simplify this down, and we have 1/9. So our limit of this equation is 1/9. Let's go ahead and do our next example. We're looking at sine function here, and we are approaching pi. Since we are approaching pi, we're going to substitute pi in. So look at sine of 2 times pi. Well, where is 2 pi? What's our sine value at 2 pi? Sine value is your y. We are here for 2 pi. We have the coordinate of 1, 0. So what is our y value? Y value is 0, so sine of 2 pi is equal to 0. Therefore, the limit as x approaches pi of sine of 2x is equal to 0. And lastly, I have a piecewise function here, and we are looking to figure out if the limit exists as x approaches 2. In order to figure out if the limit exists, we need to use direct substitution into each of these equations, and we need to figure out if as we approach from the left-hand side and as we approach from the right-hand side, are we approaching the exact same value? So let's go ahead and do that. First, we'll plug 2 in for 2x plus 1. And that's when our x is less than 2. So this is coming in from the left-hand side. So our 2x plus 1 is coming in from the left. We end up with 4 plus 1, or 5. Now let's take a look as we come in from the positive side, because this is x is greater than or equal to 2. So as we come in from the positive side, we have x, which is 2 plus 3, or 5. So both of these values are the same, which means we are approaching 5 from the left-hand side and the right-hand side. Both of our y values are getting closer and closer to 5. So there's no jump, there's no oscillation, there's no infinite end behavior. So that means that our limit here of this function is equal to 5. So direct substitution is exactly what it is. Take the x value that we are approaching and we plug it in everywhere there's an x, get a value. If you have a piecewise function, they need to be the same value coming in from your positive side and coming in from your negative side. If they're not, then the limit does not exist. So that concludes all of these lessons on your introduction to limits. If you like what you saw, go ahead and hit that subscribe button, and I'll be chatting with you later.